all of you are fine and safe. We are again back with our online classes after a short summer break. So today we are going to start with a new chapter, chapter 3, energy. Now the word energy we use in our day-to-day life, or it's a very common word, mean to say, like that of force. And this energy has got the ability to do work. If you have got energy, you can be able to do or perform work. So to do work, energy is needed. Okay, and sometimes what will happen, continuously you keep on doing work, you will get tired. Okay, and the ability to do work will become less. You won't be able to do work because you get tired after continuously doing work. Keep on doing work, you will get tired, and the capacity to do work will become less. So that means now this energy, if you have got energy, you can able to do work. That means more energy, if you have got more work, you can do. Less energy you have, less work you can do. So that means to do work, energy is needed. So to get energy, from where do we get energy? Is we get energy from the food which we eat. The food which we eat, okay, the carbohydrate, protein, fats, vitamins, all this balanced diet. Okay, this food will help us to gain or give energy. And when we get energy, then we can be able to perform work. And the amount of food varies from person to person. A person who does hard work, a laborer's work, athletes, footballers, wrestlers, okay, all these people, they need large amount of energy. That means they need large amount of food. That means large amount of balanced diet they have to take. Okay, because they have to perform a very hard work. Okay, very hard work or very difficult tasks they have to do it. Okay, they have to use plenty of energy from their side, from their body. So therefore, they need more food or more balanced diet or more proper food. They have to take it. So this food also it varies from person to person depending upon the work which they do, which they perform. So therefore, when we discuss about this word energy, the term work has also been combined with it. The work has also been combined along with the energy. So therefore we can say that energy and the work are related with each other. They are related with each other. If you have got energy, you can able to do work. If you have got more energy, more work you can do. If you have got less energy, less work you can do. If you don't have energy to do any work, the work cannot be done. Okay, so therefore they are related with each other. So when we define energy, so energy is defined as the ability or capacity to do work. Similarly, when we define work is defined when a force applied on a body produces displacement. Okay, energy is defined as the ability or capacity to do work, whereas work is done when a force applied on the body, that body should produce displacement. If the force applied on the body, if the body does not produce displacement, then the work is not done. Example, suppose you push a wall. You spend enormous amount of energy, plenty of energy you spend it, but the wall will not move. That means the wall will not produce any displacement. Displacement the distance, the particular distance. The wall will not move. So therefore, though you spend your energy here, work is not done. The work done becomes zero. So when any object you take it, and when the force is applied on that object has to move. Unless and until the object will not move, the work is not done. So the work done will become zero. So you take a drawer or a table or a chair or a stone, okay, anything you can take it. Suppose you take one example I give you, a drawer or table. A table is at one corner. If you want to displace or move the table, you apply the force on the table, you drag it, you push it, or either you pull it. When you push or pull, you are applying the force here, and when the force is applied on that table, the table will produce displacement. That means it moves. So in that case, the work is said to be done. So therefore, work and energy, they are related with each other. Now the SI unit of energy is joule. The SI unit of energy is joule. Similarly, the SI unit of work is also joule. SI unit of work and energy are same. Okay, since they are related with each other, the SI unit of energy is joule. And other unit are also being used, that is calorie. Okay, joule and calorie, CALORE, calorie. Okay, so this joule and calorie, when they are used, this unit of energy are used in terms of potential energy, kinetic energy. Okay, but whereas this calorie is used in terms of heat energy. If you measure the heat energy, the unit is written not in joule but in calorie. Okay, as well as the energy which are stored in the food also be expressed in calorie, because in food also energy are stored on it. Okay, and which energy are stored in the food is chemical energy are stored in the food. Okay, and that food which we eat, we can able to perform a work, and the energy which are stored in the food is measured in terms of calorie, as well as the heat energy and the energy stored in the food are measured in terms of calorie. And the higher unit of energy can be used, which we call it as a kilojoule and the megajoule. Okay, one is a kilojoule and another one is a megajoule. Okay, so 1 kilojoule is equivalent to 10 to the power of 3 joule. That means 1 kilojoule is equals to 1000 joule. 1 kilojoule is equals to 1000 joule. Similarly, 1 megajoule is equals to 10 to the power 6, which means 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 zeros are there. Okay, so you can write it in power. 3 zeros means 10 to the power of 3 joule. 6 zeros means 10 to the power of 6 joule. So therefore, 1 kilojoule is equivalent to 10 to the power of 3 joule. 1 megajoule is equals to 10 to the power of 6 joule. The higher unit can be used here. Okay, then again, there is a relation between the calorie and the joule. 1 calorie, okay, 1 calorie is equivalent to 4.2 joule. 1 calorie equals to 4.2 joule. There is a relation between the calorie and the joule, or approximate value is here 4.186 joule, or you can write it here 4.2 joule. So therefore, 1 calorie equals to 4.186 joule. So how it is coming 4.2 joule here is there. So after 1, it is 8. So 1 is added to one is added to this one, it becomes 2. So you know that in mathematics, if the number is greater than 5 or 5 or greater than 5, 1 is added to the preceding number. So therefore 1 is added here, so it becomes 2 here. So 1 calorie equals to 4.2 joule. So this way you can find the relation between the calorie and the joule, and the bigger unit of energy are used, that is a kilojoule and the megajoule. But the SI unit of joule is the SI unit of energy is joule. The other unit can be used calorie, and this calorie is used in terms of the food, the energy stored in the food, as well as the heat energy. Okay, and therefore the energy and the work, they are related with each other. Now there are different forms. Now let us come to the forms of energy. There are the different forms of energy like kinetic energy, potential energy, sound energy, heat energy, light energy, muscular energy, nuclear energy. So many forms of energy are there. So we'll discuss the two things here today. Okay, the mechanical energy. What is the mechanical energy? Mechanical energy means the energy possessed by the body when the body is in the state of rest or in motion. When the body are either in the state of rest or in the state of motion, the energy is possessed in the body, and that energy we call it as a mechanical energy. There are two forms of mechanical energy. One is the kinetic energy, other one is the potential energy. And kinetic energy is the energy possessed by the body when the body is in the state of motion. When the body is in the state of motion, the energy possessed by that body, we call it as a kinetic energy. Next one, potential energy. The energy possessed by the body, okay, when by virtue of its position or size, by virtue of its position or size, we call it as a potential energy. That means potential energy is the energy which a body possesses when the body is in the state of rest or when the body has changed its shape or size. The body should not be in the state of motion. The body should be in the state of rest, or either the body, the shape and size of the body has to be changed. In that case, the energy is possessed in the body, and that energy is the potential energy. Okay, so example of kinetic energy: a moving vehicle, okay, one of the example, a running water, okay, a hammer. When you raise a hammer to pierce a nail in a wooden plank, okay, when you raise a hammer, okay, and when you move the hammer, the kinetic energy is possessed because the hammer is in the state of motion. Okay, all these are the example of the kinetic energy. Even the running water, and the running water has got the ability to generate electricity, which we call it as a hydroelectricity. Okay, so all this possesses kinetic energy, and kinetic energy is given by the formula or by the relation. Kinetic energy equals to half into mv square. Half mass into velocity square is the kinetic energy. To calculate kinetic energy, half into mass into velocity square. So this is about the kinetic energy. Next one is the potential energy. The energy possessed by the body when it is in the state of rest or changing the shape or size. Example I give you: a stretched bow. When the bow gets stretched, okay, energy is possessed on the bow, okay, that is potential energy. A compressed spring. When the spring gets compressed, okay, compressed spring also has got potential energy. And the water which is stored in a dam, that water is not flowing, the water gets collected, the water gets stored in a dam, and also there also the energy is possessed in that stored water, that is the potential energy. And potential energy is given by a relation mgh, that is mass into acceleration due to gravity into height. Okay, now for this, let us take an example. This is the ground floor. Suppose you take a stone. A stone is raised to a height. You carry a stone on your hand and you just lift a stone to a height. Okay, and you keep it on a height. And this stone, since it is raised to a height, it is given as x. Let the stone is raised to a height of x. And let us consider a stone has a mass present on it, and the mass is m. Another point is the acceleration due to gravity. I have explained this in the previous class. Acceleration due to gravity. That means when a stone, when you drop the stone from the height, when you just drop the stone will fall from the height, and when it falls with an acceleration, okay, known as acceleration due to gravity. Now, why we add the three words due to gravity means because when the stone or any object is thrown vertically downwards, that object will be attracted by the Earth's gravity, because Earth acts as a magnet. They possess gravity, and due to the Earth's gravity, all the objects, when they are thrown vertically upwards, this object has got a tendency to fall on the ground. So therefore, either you take a stone, a paper, or pencil, whatever object you take it, and you drop it from the height. So that object will fall with an acceleration, and that acceleration possessed by a freely falling body, that acceleration we call it as an acceleration due to gravity. So therefore, to calculate potential energy, we use the relation mass into acceleration due to gravity into height. Okay, so these are the two types of mechanical energy: kinetic energy and the potential energy. So in the next class, we will come to the other forms of